In this video, I'm going to review the code that I presented in the Coding Challenge 1 reading on vectors. This is going to help you strengthen your understanding of vectors, as well as see an example of call by reference in order to show the benefits of being able to change the values as well as significantly reduce the memory consumption in your program. First, I want to quickly go over the libraries and define directives. In order to implement a vector, we have to do #include vector. Notice I've also done a compiler directive #define vector since we're doing this and we're not using the using namespace std namespace. What we're going to do next is we are going to go to main and we're going to see how we initialize the vector. When we initialize the vector, what I have is I have a length of 10, veclen, a location equals 4, and then I have the initialization of the vector. Let me break down each part of this code. Vector is the compiler directive that does standard vector. Here, for now, all you need to know is that this creates a vector of integers. Later in this course, we're going to go into a lot of detail about templates. After a space, we have the variable name main vector, which means that this is the vector in main. To have an initial length of the vector, we put the variable veclen here. This means that it's 10. Otherwise, what would happen is I'd have a length of 10 here. If I didn't do that, the initial length would be 0. It would just be pointing to a location on the data heap. What I want to show you next is an example of iterating through a vector. What I've done is I have an initial integer of base 5, and then what I do each time is I multiply it by 2, and then I call the .at method for iter, and that value will be equal to base. So what will happen is at 0, it'll be 5 times 2, so it'll be 10. At 1, it'll be 10 times 2, which will be 20. At 2, it'll be 40, 3 will be 80, and so on. A crucial part for the production quality compilation rules is that notice how I'm doing the iteration with a long unsigned integer. In the standard vector, this method size returns a long unsigned integer. And the reason it does that is because it's looking at a memory in the data heap. Because of this, the production quality compilation rules, specifically W conversion, require that you compare a long unsigned integer. So that is what I've done here. Next, what I do is I print out the value before. So what happens is before, this .at location is going to give me 0, 1, 2, 3, and 4. So we know that this is initially 10, this is 20, 40, 80, 160. So we expect it to print out 160 initially. Then I'm going to call the function, and then what's going to happen is I'm going to print it again. So initially it's going to say before 160, but let's take a look and see what happens in the function. So let's go to update vector. In the function update vector, I have called the vector by reference. The benefit of calling by reference is twofold. First, any change that I make in update vector will be preserved, and it's designed to be coded more simply. Second, if I don't do that, then what's going to happen is it's going to make a copy. So it'll have initial vector. If I got rid of this, it would actually make another vector, make those changes and not preserve them. So what's going to happen is I'm going to take this location that I'm passing and then update it to 88. So it's passing 4. So it's going to go, the value is going to be changed from 160 to 88. And then in main, we have the second print. So we'll print 160 and 88. So let's run this. And we see that it prints exactly what we anticipated. So let me get rid of this call by reference and show you what happens. It's going to update it, But what's going to happen is it's going to print before 160 and after 160. We see that's what happened there. The reason why is because if we didn't call by reference, it will make an entirely new copy of the vector, update that copy here, and then preserve the one in main. So if I actually were to copy this, in func, it will print out 160, 88, and then 160. Of course, I need to get the correct variable name. Sorry about that. And we see that's exactly what is done. So in order to fix this, make sure you call by reference, and all that does is do a pointer so it's significantly more memory efficient and actually preserves the results.